one likes to reinvent the wheel. Okay, most of us don't like to reinvent the wheel. I know there are some of you out there that enjoy that sort of thing. But for the rest of us, especially when it comes to designing IoT applications, reinventing the wheel, starting from square one, or any other idiom about wasting time is not part of our project plan. So, how do we avoid these kind of pitfalls for our next connected design? How do we avoid jumping through unnecessary hoops just to get the job done? With the help of the AWS IoT ExpressLink SARA-R5 Starter Kit. Hi, I'm Amelia Dalton, host of Chalk Talk. Developing a connected IoT design from scratch can be a complicated endeavor. In this episode of Chalk Talk, Harald Kröll from U-blox, Lucio Di Jasio from AWS, Rob Reynolds from SparkFun Electronics, and I examine the details of the AWS IoT ExpressLink SARA-R5 Starter Kit. We explore the common IoT development design challenges that this AWS IoT ExpressLink SARA-R5 Starter Kit is looking to solve, and how you can get started using this kit for your next connected IoT design. And before we get started, don't forget to click that link. There you can find even more information about this topic. Hi, Harald. Thank you so much for joining me.
Thanks, Amelia. Thanks so much for the invite.
And hi, Lucio. Thank you for joining me.
Hi, it's a pleasure to be here.
And hi, Rob. Thank you for joining me.
Oh, my pleasure. I'm glad I can do this with y'all.
Excellent. Okay, so first, Harald, we're talking about the SparkFun AWS IoT ExpressLink SARA-R5 Starter Kit today. But Harald, before we dig into the details, tell me a little bit about your company.
Yeah, with pleasure. U-blox is a Swiss company making chips and modules for various applications. It was founded in 1997 as a spin-off from ETH Zurich, and it's mainly active in the IoT market. And since its inception is growing with a base of around 15% annually, it's also well known for vital investments in R&D and its innovation culture. In 2022, for example, we sold above 100 million chips and modules.
Fantastic. Now, Harald, U-blox has a wide variety of positioning and connectivity solutions, right?
Yeah, definitely. That's one of our core markets is positioning. So we make and sell receivers for GNSS, so for satellite-based positioning technologies. Then we also have chips for connectivity with various connectivity solutions like Wi-Fi, Bluetooth, and the cellular ones. One of this kind is the ExpressLink module. Then we also have compute solutions, which means that the customer can run its application on our modules, on a microcontroller, for example, or in an application environment. And besides that, we offer cloud services to assist the user with our chips and modules. Also, with these products and services, we have two characteristics. So one of them is that it should be easy to implement, and the other one is they should be safe and secure. These two aspects, they don't go well together. And ExpressLink is a technology, is a module with the cloud aspect, which brings these two together. So it's easy to implement and safe and secure.
Fantastic. Now, in previous Chalk Talks, we've talked with U-blox in terms of LTE-M as well. And you guys have been in this arena for a long time, correct?
Yeah, definitely. So we are in LTE-M since 2016. So there we announced the first LTE-M module, so-called SARA-R4. And that was also the first module which got certified with major MNOs, mobile network operators, like AT&T and Verizon. So this was going pretty well. Then we decided let's do our own chipset for LTE-M. And that was 2 years later. So we announced the U-blox R5 chipset. And so we were the only module vendor which has the full stack from silicon up to the cloud. It got even more interesting around late 2021 when we teamed up with AWS and we launched the first LTE-M AWS IoT ExpressLink module.
Okay, so Lucio, let's dig into the details of the module at the heart of this solution. What was the motivation to create this solution?
Yeah, well, the module is very dear to me because there's a strong motivation to solve a number of problems that affect the IoT developers. And in AWS, I work in the IoT device support team. We're very interested, we're very motivated to make sure that our customers have all the means and all the tools available to develop rapidly and securely devices that can inject data, that can send data to the cloud. So the problem is about enabling the smallest microcontrollers to connect to the cloud. And these microcontrollers are resource-constrained devices. So they need to communicate to the cloud using the simple means that they have, which very often means just a serial port, a UART. And that's how, in fact, we can connect with the SARA-R5 modules. And then with a number of sensors that are actually sensors and actuators, the connection to the physical reality, right? So that's where we get the data from. That's where we apply control to. And these things typically have to sit on very, very tiny boards, very often are embedded, are invisible to the end user. And so they have to operate on battery with very low power. They have all sorts of constraints because to create a good product, our developers need to really be able to make an object that is self-sufficient and a device that is invisible to the user, that is completely embedded in the application. And so there are a number of problems for these developers. All these constraints come to eventually make the life of the developer really hard. In particular, the first problem is that interface between the microcontroller and the communication modules has grown over the years. A number of commands and flags and configuration details have grown enormously. And what is normally used for this communication channel, which we refer to as an AT command set, is in reality a standard that has been developed over the last 40 years. So you have to imagine there are 40 years of legacy there. And it's grown by accretion to become something very untractable eventually. As we say, it's non-human readable, so it has become very cryptic, kind of a science in itself just to master as a command set. The second problem is that poor little microcontroller, resource constrained as it is, it has now to control the AT commands, send the AT commands to the module, but on top of it, he has to take care of an additional layer of complexity, which is the access to all the services that the cloud has to offer. So there are protocols for the device shadow, for the over-the-air updates, for the localization, for security, for securing the device and monitoring the health of the device, what we call the device defender. So these are layers and layers of code and complexity that need to be put on top of communication with the module. And then there is a third level, perhaps is the most important. It is about the security. Communicating over the internet is always challenging. Connecting to the cloud, in particular the AWS cloud in this case, can be especially challenging for a small microcontroller because the level of cryptographical security that is required between the device and the cloud can be very high. There's a very high wall to climb before you can push your data into the cloud. And so that means that there's a problem with provisioning the device with credentials, keeping those credentials secure in the application, rotating those credentials, and so on and so on. It's a science in itself. It is important, as we know. It is probably the most important aspect that effect creates room for vulnerabilities for millions of devices, potentially, if not taken care. The solution to that is something that we work together with U-blox in creating a new module that is AWS IoT ExpressLink. And these ExpressLink modules solve the particular problems that we discussed now. The instruction set, the AT command set that we call familiarly, is shrunk. So we took the opportunity to rethink this AT command set, reduce it in size considerably, and make it human readable as we were at it, and redesign it at a more abstracted level so that it was appropriate for communicating with the cloud directly, not just connecting to the internet, but communicating to the cloud. As we elevated this conversation, as we added this abstraction, we could include now in that protocol the support natively for the services that an IoT device requires. So over-the-air updates are built in this protocol. Device shadow is built in this protocol. And also localization and health and security and monitoring of the device is also naturally supported and is part of the basic set of commands that we get for ExpressLink modules. And lastly, any module that claims to be an ExpressLink module comes pre-provisioned. So it already contains security credentials. And as U-blox ships it to customers, it already arrives ready out of the box with root certificate authority, with a birth certificate that is unique per device, with a unique identity of the device, a unique name or number if you want. It contains private key, OTA certificate, and additional certificates that can be used for the host processor to perform over-the-air updates. An enormous amount of complexity is now removed from the shoulders of the developer because all these things are already built in. And you don't have to reinvent these things. They're done well up to the latest and greatest security standards. So it's a huge time reduction, it's a huge cost reduction, but it's also a great relief in terms of security of the resulting solution. And so I have just one more slide where I show you side by side the two command sets. The contrast is starking. So you see on the left side the index of the U-blox cellular modules manual. We're showing page 12 of 1039. And this is the manual that has chapter by chapter explains all the commands. And then you see on the right side of the slide, there is just 20 or so commands that are part of the ExpressLink command set. And this is page 2 of a grand total. The entire programmer's guide is now reduced to 37 pages. So that's a visual for the reduction in complexity, if you want.
So, Harald, how does the SARA-R5 AWS IoT ExpressLink help solve these issues?
Yeah, that's an excellent question. So we've seen in the previous part the problems which Lucio pointed out. So it has 3 features which are addressed to solve these problems. And one of them is security. So our module has a hardware-based root of trust with a dedicated secure element in it, which means that we can offer out-of-the-box security for the customer. And in addition to that, the module is pre-provisioned to the customer's AWS account. All the handling with security procedures and certificate is kind of not necessary anymore. It is done in the background by our integrated security and the AWS cloud service. Then besides that, it has dedicated AT command set. It's the ExpressLink AT command set, which is much easier to learn and much easier to handle. It has only around a dozen AT commands, and also the AT commands are implemented in a way that they're human readable and easy to absorb and to use. As the third feature to address, typically the customer has to maintain a lot of software libraries which correspond to the AWS cloud counterpart on his host microcontroller. Client software library for the over-the-air updates for AWS IoT Shadow and AWS IoT Device Defender. These libraries with the SARA-R5 AWS are not necessary anymore because they are integrated into our module and the customer does not have to maintain and to install and to configure them. So they come as part of the module firmware. Also, it has the well-established SARA form factor with 16 by 26 millimeter. It has a global LTE-M coverage, and it has a localization option. So besides sending data back and forward, the customer can locate the device in the AWS cloud from the signals of the mobile radio towers with a service which we have in the field since a couple of years. It's called the so-called cellocate service. So not even a GNSS receiver is necessary to get a location in the cloud about this device. Also, it has a good coverage with 23 dBm output power and only 0.5 microamp deep sleep mode.
Okay, so Harald, certification and a broad range of coverage is vital for IoT devices today. What do these aspects look like for this solution?
Yes, so definitely certifications and coverage, they play a vital role, and the SARA-R5 AWS can be operated everywhere where LTE-M coverage is available. That is large parts of Europe, North America, as we see on this map, parts of South America, Australia, Japan, and New Zealand. And within this LTE-M coverage map, we did, and we are doing a lot of certifications. So we certified with the major US operators, Verizon, AT&T, also in Japan, GTF, Shoteki. So it offers a comprehensive set of certifications to connect almost everywhere in the Western Hemisphere. And if someone is operating this device in an area where we didn't certify with a carrier there, there's no reason to panic. It can also run in a roaming setting when LTE-M coverage is given.
Okay, so Rob, tell me more about this SARA-R5 starter kit. What was the motivation to create this kit, and what kind of cool stuff does it contain?
Thank you. And again, thanks for having me here for this. For me and for a lot of SparkFun customers, one of the issues is, what do I need to get this up and running? You know, I could have the module in my hand, but what am I going to do with that? So it was our goal to put together a kit to give you everything you need out of the box. The SARA-R5 is an incredible chip, and we wanted to create a platform just to make it easier to work with and to expand upon. And to that end, we developed the SparkFun AWS IoT ExpressLink SARA-R5 starter kit. And we built this chip onto a platform that includes a quick connector, which is a simple solderless I2C connector, along with several other features that allow for rapid expansion and prototyping of the SARA-R5 ExpressLink. So let me start quickly by just telling you what the kit contains, and then I'll go a little bit more in depth about its capabilities. The kit includes a SARA-R5 module mounted on a SparkFun Micromod asset tracker carrier board, into which a SparkFun Micromod processor board can then be inserted. And that'll allow the module to be used with many different microprocessors. Now, an ESP32 processor board is included in the kit, and that'll allow you to run examples or demo applications. There's also a hologram SIM card for global use. Additionally, there's an LTE antenna plus a Micromod update tool. Now, most of these items are pretty self-explanatory, like the LTE antenna, the SIM card, but some of them I feel could use a bit more looking into, so let's do that. The centerpiece of this kit is the Micromod Asset Tracker Carrier Board, which hosts the SARA-R510 AWS, providing secure cloud LTE-M data communication for multi-regional use. As the guys talked about, it's global, which is great. Now, it's got an integrated ICM 20948 inertial measurement unit, or an IMU, for 9 degrees of freedom orientation and movement detection. Now, since it supports wake on motion, say if you want to send a message if your asset is moved, the asset tracker can do that simply. And the board also has a built-in digital microphone, and therefore it can also send an alert as soon as a noise is detected. Now, there's a built-in micro SD card socket for data logging, as well as a SIM card port and a pair of SMA connectors for LTE and GNSS antennas.
Okay, so Rob, what kind of power options does this board have?
We've got several options depending on what you're doing. Power options for this include both USB-C and LiPo battery. And for the latter, the board has a built-in charging circuit and a battery fuel gauge. But you've also got the option to provide power via the breakout pins. And speaking of breakout pins, while we're here, there are over 24 pins broken out on the board, including analog, digital, PWM, SARA I2C, SARA USB, and Quick, among others. Now, there are also 3 onboard buttons for reset, boot, and SARA on. There's an onboard Quick connector, allowing for a whole host of expansion and sensor options. SparkFun's Quick Connect system uses 4-pin JST connectors to quickly interface development boards with sensors, displays, relays, things like that. And this allows for rapid prototyping using the I2C protocol without the need to solder.
Excellent. So can you tell me a bit more about this Quick I2C protocol?
Absolutely. Quick is something we developed at SparkFun, 5 years ago now. For those of you who remember having to solder 4 wires every time you wanted to work with an I2C board, the Quick protocol is, I might go as far as to say a lifesaver, but it's at the very least certainly a huge time saver. Most of our Quick breakout boards contain 2 Quick connectors. So by using our polarized Quick cables, not only can you exponentially increase the rapid in your rapid prototyping, but you can also daisy chain dozens of boards together, allowing you to create literally millions of prototyping projects. Now, let's get back to the kit itself. The included Micromod update tool is designed to simplify communication directly with the U-blox SARA-R5 module using U-blox's sophisticated M-Center cellular evaluation software. If you're familiar with U-Center, U-blox's GNSS evaluation software, you'll know how excellent their software is, and M-Center is every bit as good. You attach a USB-C cable, and you'll have direct access to the SARA-R5 module. Now, it uses the same M.2 port as your processor board, so just insert it there, screw it in with a screw, and you're good to go. And finally, in this kit, there's the included ESP32 processor board. The asset tracker will work with any of our Micromod processor boards, but because it offers so many features and can be configured in so many different ways, some processor boards may be a better choice for your application than others. We've included the ESP32 processor board with this kit as it's just a fast and powerful processor and really good for testing and trying out your first sketches. It's got a dual-core Tensilica LX6 processor with clock speed of 240 megahertz. It's got 128 megabits of onboard flash memory, and that's expandable to 16 megabytes of external flash memory. It's also got 520K of SRAM. And perhaps my favorite spec, the ESP32 processor board has Wi-Fi and dual-mode Bluetooth connectivity. And with a number of processor boards to choose from, you may find that a different processor better fits the needs of your project at some point down the road, but this one will at least get you well on your way.
Cool. So can we talk a bit further about the AWS IoT ExpressLink supporting assets?
Sure. I mean, regardless of how fast, powerful, or impressive our hardware is, or your hardware is, it's little more than a fancy paperweight if you can't program it to do exactly what you want. And luckily, there are so many tools available for programming, and they're really phenomenal. The AWS IoT ExpressLink SARA-R5 starter kit product page has a ton of links to get you up to speed with everything. We've got documentation on the Micromod ecosystem, on the Asset Tracker carrier board, U-blox SARA-R5 LTE-M module. Now, there are links to the AWS IoT ExpressLink website, FAQs, programmer's guides, example codes, and a ton more. And if you want to really dig deeper, just follow the links on our product page, and that should give you everything you need to know.
Awesome. Well, this was great. Thank you so much for joining me, Rob.
Oh, thank you.
And thank you for joining me, Lucio.
Thank you. It was a pleasure.
And thank you, Harald, for joining me as well.
Thank you so much, Amelia.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it. It's right across the top. Or head on over to YouTube, youtube.com/EEJournal.